Okay guys, so things are getting more interesting dito sa ating topic na pressure in static fluids. So ngayon, i-check naman natin yung variation in pressure kapag meron tayong different fluids na involved. No? So, ang unang problem na sasagutan natin is from problem 3-144 from Fluid Mechanics, Fundamentals and Application by Sengel and Simbala. Okay? So, the lower half of a 12-meter high cylindrical container is filled with water with a density of 1,000 kg per cubic meter, and the upper half with oil that has a specific gravity of 0.85. Determine the pressure difference between the top and the bottom of the cylinder. So, ang kailangan nating ma-determine is yung pressure difference between the top and the bottom of the cylinder. So, we have a pressure on the top and a pressure on the bottom. So, ang kailangan nating makuha is yung pressure difference nila. And since this is just a continuation of our lectures, we learned from our previous lecture that P2 minus P1 is equal to rho GH. Diba? So, pag meron tayong kinukuhang pressure difference, so our pressure difference is equal to rho GH. But on this case, meron tayong dalawang klase ng fluid dito, no? So, kailangan maipag-add din natin yung pressure generated by these two fluids, no? So, in here, what we could say is that the pressure at the bottom minus the pressure on the top is equal to the density of our oil times the acceleration due to gravity and the height of our oil plus the density of water times the acceleration due to gravity and the height of the water. So, yan ang gagamitin natin to calculate yung pressure difference. And by the way, this right here is our pressure difference. So, once masolve na natin itong nasa right side ng ating equation, that will give us our pressure difference. Okay, so now, substitute na natin ang ating mga values. Kailangan natin makuha yung density ng ating oil. So, we have the specific gravity here, which is 0.85. And in order to get the density of the oil, we have to multiply that to the density of water, diba? So, the density of oil is equal to 0.85 times the density of water, which is 1,000 kg per cubic meter, times the acceleration due to gravity, 9.81 meter per second squared, times the height of our oil. So, since it is clearly mentioned here that our 12-meter high cylinder is filled half with oil and half with water, therefore, our height of the oil is equal to 6 meters and our height of water is equal to 6 meters. So, we have here 6 meters. Then, we will add ang ating density of water, which is 1,000 kg per cubic meter, times the acceleration due to gravity, times the height of the water. So, having this equation right here, our answer will be in Newton per square meter, diba? And we know that Newton per square meter is equal to Pascal. But since ang required natin is to express our answer in kilopascal, we better convert our given values here into kilopascal para yung makuha na natin is yung right answer. So let us include the conversion factor dito, no? So, we will multiply our terms by 1 kilopascal over 1,000 Pascal. The same here, 1 kilopascal over 1,000 Pascal. Okay? So, therefore, our pressure from the bottom minus pressure from the top is equal to 0.85 times 1,000 times 9.81 times 6 divided by 1,000 plus 1,000 times 9.81 times 6 divided by 1,000 is equal to 108.89 kilopascal. And this is our final answer for this question, which is equal dito sa answer na given sa book. Okay? Okay, so now let's go to the second question. Okay, so we have here a cylindrical container containing 5.8 meters of water covered with 3.2 meters of kerosene with a specific weight of 8 kilonewton per cubic meter. Find the pressure at the interface and the bottom of the tank. So, ito yung illustration ng ating given. No? Meron tayong tank kung saan we have water here with a height of 5.8 meters and the specific weight is equal to 9.81 kilonewton per meter squared, while we have kerosene in here with a specific weight of 8 kilonewton per cubic meter and with a height of 3.2 meters. Now, our total height here is equal to 9 meters. So, kailangan natin makuha kung ano yung pressure dito sa kanilang interface and in here sa bottom ng tank. Okay, so unahin natin yung pagkuha ng pressure sa interface. So in here sa ating interface, the only fluid above it is the kerosene. Therefore, we can apply our formula. The pressure in the interface is equal to the density of the kerosene times the acceleration due to gravity and the height of the kerosene, which is also equal to the specific weight of the kerosene times the height of the kerosene. So, substitute na natin yung ating mga value. The pressure in the interface is equal to the specific weight of the kerosene, which is 8 kilonewton per cubic meter times the height of the kerosene, which is 3.2 meters. Therefore, the pressure on the interface is equal to 8 times 3.2, which is equal to 25.6 kilonewton per meter squared, which is also equal to 25.6 kilopascal. So this is our final answer here. And then we'll have to get the pressure at the bottom of the tank. So B is for the bottom of the tank. Okay, so now we have two fluids above the bottom of the tank. So, kailangan i-consider natin yung dalawang fluids na yan. So, therefore, the pressure at the bottom is equal to the specific weight of the kerosene times the height of the kerosene plus the specific weight of water times the height of the water. So, substitute natin yung ating mga value. Specific weight of kerosene is equal to 8 kilonewton per cubic meter times the height, which is 3.2 meters, plus the specific weight of water, which is 9.81 kilonewton per cubic meter times the height of the water, which is 5.8 meters. Therefore, the pressure at the bottom is equal to 8 times 3.2 plus 9.81 times 5.8 is equal to 82.498 kilonewton per meter squared, which is also equal to 82.498 kilopascal. And this is our final answer for this problem. Bago tayo magpatuloy sa ating discussion, we would like to ask for your support by subscribing sa ating YouTube channel. Please click on the notification bell para lagi kayong updated sa mga videos na ipopost namin. Okay, so finally, our third problem. We have here now a tank, no? And here, makikita natin na iba't ibang types of fluid na yun nandito. In the figure below, if the atmospheric pressure is 101.03 kilopascal and the absolute pressure at the bottom of the tank is 231.3 kilopascal, what is the specific gravity of the olive oil? So, ang given muna natin is our atmospheric pressure, which is equal to 101.03 kilopascal, di ba? And then, the absolute pressure at the bottom of the tank is equal to 231.3 kilopascal. Okay, now in order to proceed with this calculation, we have to get the gauge pressure at the bottom of our tank. So how are we going to do that? If you remember sa ating lecture video, we have a formula in which the absolute pressure is equal to the gauge pressure plus the atmospheric pressure, no? So now we will get the gauge pressure, which is equal to the absolute pressure minus the atmospheric pressure. So therefore, our gauge pressure at the bottom is equal to 231.3 kilopascal minus 101.03 kilopascal. And this is equal to 130.27 kilopascal. And this gauge pressure is the pressure at the bottom. Okay? Okay, so this is our given pressure there. So, ang pinahanap sa atin is yung specific gravity ng olive. Lahat is given. Water is known. Sea oil has a specific gravity of 0.89 and the mercury has a specific gravity of 13.6. So, ang hindi natin alam is yung specific gravity ng olive. Okay, so we have the pressure at the bottom of the tank, which is 130.27 kilopascal. And we know that this is a result ng lahat ng fluid na nasa itaas ng ating bottom, no? So therefore, in order to get this pressure, kailangan i-add natin lahat ng involved na fluid dito. So that means the pressure at the bottom is actually equal to the density, acceleration to the gravity, and height of our mercury plus density, acceleration due to gravity, and the height of our olive plus density, acceleration to the gravity, and height of our water plus the density, acceleration due to gravity, and height of sea oil. Okay? So now we have to substitute the values of these variables para ma-calculate na natin yung specific gravity ng olive. Okay, so we know the value of our pressure at the bottom, which is 130.27 kilopascal. Diba? So unahin natin to. Ang values ng ating mercury, no? So first, we need to get the density of the mercury. And to get that, we need to multiply the specific gravity with the density of water. Then, the acceleration due to gravity, 9.81 meter per second squared. And then, the height of mercury, which is 0.4 meters. Okay, so katulad ng mga ginawa natin sa previous problems natin, tignan muna natin ano ba yung unit natin dito, no? So we have kilogram meter per second squared, which is Newton. And then we have cubic meter in the denominator and meter in the numerator. So that means our unit here will be Newton per meter squared, which is also equal to Pascal. But since our pressure at the bottom is in kilopascal, better convert everything into kilopascal para mas mapadali ang ating calculation. Okay, so we'll do that. So this is already in Pascal, so we'll convert this into kilopascal. 1,000 Pascal to 1 kilopascal. Okay, then plus our values for the olive. Okay, and we don't know the specific gravity of olive. Multiply that to the density of water. Then the acceleration due to gravity. the height of the olive, which is 2.9 meters, and then convert from Pascal to kilopascal. Okay? Then plus, we'll have now water in here. Okay? So, the density of water, which is 1,000 kilogram per cubic meter, times the acceleration due to gravity, times the height of the water, which is 2.5 meters, and then convert that into kilopascal. Finally, we have sea oil. Okay, and the specific gravity of sea oil is 0.89. So, plus specific gravity, which is 0.89, times the density of water, times the acceleration due to gravity, and the height of the sea oil, which is 1.5 meters. Then convert that into kilopascal. Okay, so our left side of the equation is in kilopascal and the right side is in kilopascal. So therefore, if we solve for this equation, we are going to get the specific gravity of our olive, which is dimensionless. So all of the units will be cancelled out. So we'll not be worried about the dimension, no? Because we know that everything is consistent, no? Okay, so now let's try to solve this. We have on the left side of our equation, we have 130.27. And this is equal to 13.6 times 1,000 times 9.81 times 0.4 divided by 1,000. This is equal to 53.366. Then plus the specific gravity of oil, or olive I mean, times 1,000 times 9.81 times 2.9 divided by 1,000. This is equal to 28.449. And then plus 1,000 times 9.81 times 2.5 divided by 1,000. This is equal to 24.525. Then plus 0.89 times 1,000 times 9.81 times 1.5 divided by 1,000. This is equal to 13.09635. Okay, so we will work out our given, no? So, isolate natin itong term natin na ito. Okay, so all of this will move to the left side of our equation, which will be 130.27 minus 53.366 minus 24.525 minus 13.09635, which is equal to 39.283, and this is equal to 28.449 times SO. So ito yun, no? Sinulat natin dito sa right. So therefore, working for this, the specific gravity of olive is equal to 39.283 divided by 28.449. This is equal to 1.38. So this is our final answer for this problem.